Hi, kids. All right. Another Newton's Law problem, dynamics problem. We have our 20 kilogram box again. It's sitting on an incline this time. I'm telling you that the coefficient of static friction is 0.5, the coefficient of kinetic friction is 0.3, and then the question is, will the box start moving? Moving. And then if it does, what is the box's acceleration going to be? So as always, process. Our first step is going to be we want to draw a free body diagram. Though I cannot emphasize this enough, guys. For your free body diagram for inclines, make your picture big. I see so many students make a teeny tiny little picture, and then they can't figure anything out because it's too small. So make your picture big, okay? If you have to use half sheet of paper, do it. Okay, but here is my picture. So here is my incline, 15-degree incline. Okay, here is my box on the incline. Okay, I know it looks just like a box on an incline. Actually, let me draw it a little bit better because, after all, I did minor in art, so I want to make sure that it looks nice. But there's my box on the incline. And then, as always, our first step is to draw your free body diagram. So if I draw forces that are acting on it, I have the force of gravity down. So Fg pointing straight down. I have my normal force pointing that way. And then for this problem, I'm going to have the force of friction pointing up the incline because it wants to slide down. So friction always goes against motion or the direction that it wants to move. So it's like that. Okay, so again, I am going to need to break one of these vectors into its components. Here's where you have to kind of pretend that x is now this way, it's parallel to our surface, okay? And y is this way, perpendicular to the surface, okay? And this is why you got to make your picture big, because if you don't do this, you're going to get confused. This one is parallel, this one is perpendicular, this one is neither, so I have to break this one into its components. So when you draw this, I want to draw it perpendicular to the incline, so it's this way. That would be my FGY, okay? Because again, it's perpendicular. Now look at your picture after you draw yours and see, is it perpendicular? Does it make a right angle? Because if it doesn't, then redraw it, fix it, okay? And then draw it this way parallel, so this is going to be my FGX. So again, this should be parallel to this. If it's not, fix your picture. Don't draw it this way, okay? Because that's not parallel to the surface. You always want to go to the surface, okay? But there's my picture. So that's my first step. Second step, as always, is to write your equation. So the sum of fx is going to be, well, horizontal, I have this one and I have this one. So I'm going to go this minus this. If you're not sure, you have to guess. If you guess right at the end, your acceleration is going to be positive. If you guess wrong, your acceleration at the end is going to be negative. I'm going to guess this minus this. So I'm going to go FGX minus FF, and then that would be equal to MA. And then my sum of my Y is going to be, I'll go with this minus this. It doesn't really matter. You can go either way because, remember, the y side is always 0 because it's not going to accelerate into the incline or off the incline. So I have my two equations, okay? Then it's a matter of plugging stuff in. But again, process, first step, second step right here, okay? So if I plug stuff in first, if I want to see if it's going to start moving, I'm going to set this equal to 0. Okay. Actually, I'll set it to equal to MA. I'll just do it that way. But if it is going to start moving, this has to be bigger than this. So if it's not going to start moving, then vice versa, and then it will move. But remember, FF is, as we talked about before, coefficient of friction times the normal force. So I first have to find my normal force. And if I do this, this is going to be FGY. Now, here's where you guys have to make your picture big. It's pretty obvious if you make a nice big picture. This is 15 degrees. This top angle is also going to be 15 degrees as long as you draw it this way. So that this is also 15 degrees there. So that means this is adjacent. So I would say This is my FG, which is mg, so it's 20 times 9.8 times the cosine of 15 minus Fn equals 0. So then I can solve that for Fn, which I'll do in a minute. You guys can solve it too. We'll pause it, and then you guys can solve it, and I'll solve it. And then on this side, I am going to have Fg perpendicular, or Fg parallel, which is the x component, so the parallel. So it would be 20 times 9.8 times the sine of 15, and then minus mu. So first I want to see if it's going to be moving, which is going to be 0.5 times whatever I get for my normal force. So that I'm going to plug in, and then I'll get 20 times A. So first I want to see if it's going to work, so I'm going to pause it. We'll see if it is going to accelerate. You guys can do the same. So pause, be back in a... Hi, kids. All right. So I assume you did the calculations like I did. But when I did my calculations here, so I get my Fn to be 189 newtons. And then when I did solve for Fgx, I got 50.7 newtons. So then when I solve for f of f, I get 94.5 newtons. Okay, so here's where you got to interpret this. So look, friction is bigger than Fgx. So if my static friction is bigger than Fgx, that means that, you know what, it's not going to move. So box is not going to move, I'm all done. But again, there could be a follow-up question. Let's say that there was a follow-up question. The question said, well, if you were going to push the box, how much force would you have to push down the incline in order to get it to move? Well, that would be, okay, then I'd have to take 94.5 and subtract this, and I'd have to apply at least that much force in order to get it to move. So that's one way. If this did work out, so it was bigger, then you would have to go back and sub in, okay? I would have to go back and sub in my 0.3 here, and then I could solve for my new A, okay? But there you go. Bye, kids.